Okay, they want us to do the indefinite integral of this fraction. They give us a hint. Rewrite as two fractions, like like that. So I'm gonna do that. So I'm gonna say, okay, so this becomes the integral of 8x, just the 8x, over the x squared plus 1 dx plus, and then the separate, and I'll do it over here in different color maybe. The integral of 8x plus 3. No, no, wait, what am I doing? To get the 8x, 3 over x squared plus 1 dx. That making sense there? I just separate, right? Because I just said, look, 8x plus 3 is just 8x plus 3. Yeah, maybe that's weird. So I did what? Let me show you. I just said, look, 8x plus 3 over x squared plus 1. That's basically just 8x over x squared plus 1 plus 3 over x squared plus 1. It's just common denominator, right? So then if we're doing the integral of it, well, then this is just two separate integrals, each one with their own dx. That's all that we just did. Okay, so let's just do them separately. Why? Well, the reason is because they need different u subs. So first off, this one, I need a u sub. Well, what are you going to do? You're going to let u be the denominator. Let me just separate so the work will be so we can not get confused. So this one, and I'll put the plus sign right on the line there. Okay, so for this one, the u sub is going to be this denominator. Why? Because that's one higher power than it's higher power by one than the top. So then the du dx will be 2x, right? Just bring down that 2, subtract 1, and that part's a 0. Okay, and then multiply, see both sides by dx. Cancels. So du is 2x dx, isn't it? Let's just bump this 8 to the front because he's not doing anything really important. So 8 times the integral of, now the bottom is just going to be u. The top is just going to be x and dx. I put the 8 in the front. So let's multiply both sides here by a half. Boom. And so we get the fact that x dx is a half du. This x dx right there is going to become a half du. X dx is a half du. So this integral becomes 8 times the integral of, um, let me do this carefully. The u's on the bottom, and the half dx is on the top, right? Okay. Now what should we do from there? We should move this half to the front. Let's get some more space here. Okay. Oops, go ahead. There we go. So move this to the front. So this will be 8 times a half. The integral of, I'm going to make it 1 over u du. Oh, wait, oh, I'm sorry. This should have been du here, right? It's a half du. Important that we got it all in terms of u. So this is, so now we can do the, what's the integral of 1, we're going to do the antiderivative now. What's the antiderivative 1 over u? It's natural log absolute value u. And then this 8, half of 8, which before, leave that in the front. Right, we good there? Now, right, because the derivative of natural log is 1 over, so there it is. The absolute values should be there. It'll give you credit if you forget them, but it should be there. And let's go back to the original letter now. 4 natural log absolute value. And then what was u all along? It was x squared plus 1. Okay. So we did the antiderivative of that side, plus now we got to do the other side. How are we going to do the other side? And you might think, we'll do a u sub, let it be that. No, that won't work. If you do a u sub, same u sub, it's not going to work because you see it right here. Du dx would be 2x. Even see, we'll get along, get x. Yeah, but x dx, there's no x here. There's no x. What am I going to do with x dx? I'm stuck. That won't go anywhere. Instead, you have to look at this for a second. Let me pull the 3 out to the front. I'll yank that 3 to the front. And we get 3 the integral of 1 over x squared plus 1 dx. So you just kind of have to recognize that. Let me grab space. Let me help you recognize that. I think it's there. Yeah. Here we go. Let me clean this up a bit. Here we go. Yeah, there's a nice little formula. Yeah. Do you recognize it now? The integral of something like that is arctan. That's arctan. And the a is just 1. So it's just arctan right there. So you just I'm not going to use it. I'm not going to I'm just going to go look. It's 3 times, and that's arctan of just x. If you want, I can be more formal. This is like the u squared, and this is like the a squared. Oops. So I'm looking at this formula right here. I'm saying, right? And so it's going to be 1 over a. So that's just 1 over 1 because a is 1 right here, right? A squared is 1, squared is 1. So it's 1 over 1, which is just 1. Arctan of u over 1, and u is x. So that's why it's just arctan of x. So that's it. There's nothing more to do there. It's just arctan of x. Let's bring this down. So now we can say, okay, plus 3. Whoops, that was not a good 3. 3 arctan of x. And of course, we have our plus the constant. So there we did it. The integral is those two parts plus the constant. Let's see if we get it right. So they put the 3 arctan in the front here. That's fine. 0.5 times 8, that's 4. Natural log of x squared plus 1, or they did the absolute value version as well. We got it. Doesn't matter whether you put this first or that first, and then they put in the constant for us. And so there we go. So sometimes integrals must be done in two separate parts. If you have like a fraction, like 8x plus 3 over x squared plus 1, you separate it into two fractions. Why? Because the u sub works on the left side, but that u sub would not work for the one on the right. So you have to do them separately. So that's the moral of the story there. And so there we go.